Hi everyone, my name is Anna Nemenzo and I'm a student in Chemistry 123 at CCBC. Today I'm going to show you how to solve the molality in the freezing point of a solution. So our question for today says, the freezing point of a solution containing 0.546 grams of a human hormone, a non-electrolyte dissolved in 15 grams of benzene is measured. The molar mass of the human hormone is 776 grams per mole. The first question says, what is the molality of the solution? And the second question is asking for the freezing point, but we're going to solve that later on. So first, we need to know the formula for the molality, which is small m equals to moles of solute divided by the kilograms of the solvent. Now, just a quick reminder that molalities are more convenient than molarities in experiments that involve significant temperature change. So in this case, we are solving for the freezing point that involves temperature change, but we're going to do that in part B. So first, we need to figure out the moles of the solute. The solute in this problem is going to be the human hormone, which is given to us in 0.546 grams. So we just need to convert grams to moles. So to do that, we can write moles of solute, which is the hormone, and take 0.546 grams times 1 mole divided by the molar mass of the human hormone, which is 776. So just plug that in on our calculator. 0.546 divided by 776 is going to equal to 7.04 times 10 to the negative 4. And then the grams will cancel out in this situation and we're left with moles. So that's moles of the hormone. Now, it is important to maintain the 3 significant figures because on our problem, it was given to us in 3 sig figs. So now that we figure out the moles of the hormone, we can then solve for the kilograms of the solvent. Now the solvent in this problem is going to be the benzene, which is given to us in 15.0 grams. We just need to convert grams to kilograms. So to do that, we can write kilograms of the solvent, which is the benzene, and take 15.0 grams and convert that to kilograms. So 1 kilogram is equal to 1,000 grams. So 15 divided by 1,000 is going to be 0.0150. Then the grams will cancel out and we're left with kilograms. And that's the kilograms of the benzene. So now that we figure out everything that we need for the formula, we can then just plug it in. So molality will equal to 7.04 times 10 to the negative 4 moles of the hormone, or the solute, divided by 0.0150, that's kilograms of the solvent, or benzene. So just plug that in on our calculator. 7.04 times 10 to the negative 4 divided by 0.0150 is going to equal to 0.0469. And then making sure that our significant figures is 3. So then we just figure out the molality of the solution. Alright, so now that we figure out the molality, we can then solve for the freezing point. So to do that, we need to know the formula for the freezing point of a solution. So the freezing point of solution will equal to the freezing point of the pure solvent minus the freezing point depression of the solution. Now we already know the freezing point temperature of the pure solvent, which is given to us. We just need to find out the freezing point depression of the solution. So to do that, we need to know the formula for the freezing point depression, which is freezing point depression equals to freezing point constant of the solvent multiplied out by the molality. Alright, so we also already know the freezing point constant, which is also given to us. We just need to plug that in on our calculation. So the freezing point constant of benzene is 5.12. That's Celsius per molality. Times the molality that we figured out earlier, which is 0.0469. Right, and thus plug that in our calculation, so 5.12 times 0.0469 is equal to 0.240, and then the molality will cancel out and we're left with the Celsius. And then 240 maintaining our three significant figures. So that's our freezing point depression. So now that we figured that out, we can then solve for the freezing point of the solution. So the freezing point temperature of the solution is equal to the freezing point of the pure benzene, which is 5.50 Celsius, minus the freezing point depression, which is 0.240. Now, just an important side note, the freezing point of the solution will always be lower than the freezing point of the pure solvent, which in this situation proves that. So then we can plug that in our calculator. 5.50 minus 0.240 is going to equal to 5.26 Celsius. So then we just figure out the freezing point temperature of our solution. Alright everyone, I hope this video tutorial will be helpful for you guys. Thank you.